I died. And I got 25 points. This game is called Pixel Dodge, and the aim of the game is to dodge the pixels. For every pixel that goes past you, you get 1 point, and there are 3 levels that get progressively harder. So, let's get on with making it. Start a new project. Pixel Dodge. So we'll have a game state variable, and we will set this to 0 on start. We will have a logic loop that checks, is the game state equal to 0 or is the game state equal to 1? We can put comments here if we want to make this clear. 0 before playing, 1 playing, and when it starts I just want the player to see a picture of an alien. Then when they press the button, we want the game to start. If the game has not started, then you can set the game state to 1. This is also a game where we are going to have a score, so we'll need to have a variable for that. We'll call it score, and we will set the score to 0 to begin with. So what happens when the player starts the game? I want to show what level the player is playing. Show string L, show number. Oh, I put the score in the wrong place. We're going to have another variable, current level. The current level is going to start at 1 because players will also always start at 1. When the game starts, the player will see L and then the current level. For example, 1, L1. Let's repeat that 2 times. So we're going to make our first function for cleaning the screen, just like last time. Great, we got the function. We just need to call the function. We're going to increment the game state to 2. This is so that we can then control really the second part of the game. That's all introduction, essentially. You see the L1, but then of course we need to play the game. So we're going to set game state to 2, playing intro, and then 2 is playing game. The player has kind of like a little spaceship or something that's avoiding asteroids. And that little spaceship, i.e. 1 pixel, is at the bottom of the screen. So of course the computer needs to know where to start. That spaceship just always stays on the bottom of the screen, moving left and right. We may as well just start it in the middle. There are 5 pixels. Remember, the indexes are like this: 0, 1, 2, 3, 4, and that means that its X position is 0, 1, 2 to begin with. So let's start a new variable, player X pos. We'll just set that right at the beginning of the game. Now we can plot that. Y coordinates start at the top and they increase as they go down. We need the Y coordinate there to be 4. So 0, 1, 2, 3, 4 would be the 5th row down. We want to prepare the level. And to do that, we're going to use a function, make level. And this level is actually going to be made up of 2 arrays. We're going to have one array that has the X position of all the pixels that are dropping, and another array that has all the Y positions. And that's what we're going to get the microbit to create randomly with some rules. So we're going to call this function when the player presses the A button to start the game. At that time, I think we're going to plot the player's X position. Okay, on the easy level, there are just going to be less pixels to dodge, and they're going to be less frequently falling, so there'll be a bigger gap between them. On the harder levels, there'll be more pixels to dodge, and they'll be closer together, so that's what makes it harder. To get the microbit just to design all 3 of these levels automatically, the first thing we're going to do, make a new variable, which is total pixels to drop. And we're going to set the total number of pixels to drop to the current level multiplied by 10. And then we're going to create the first array. For this one, we'll create the X positions, which is the random, which column is it going to fall down. X pos for all drop pixels. To start off with, we're just going to make it an empty array. We're going to use a loop to create this from 0 to the total number of pixels. But if the total number of pixels is 2, that means that the index is going to go 0, 1, 2, 3. So we actually need to stick in a little -1 here. Good. Then we need to randomly generate a column. So we need a new variable, rand_x_pos, and we're going to set the random x position to pick random between 0 and 4. Now we can add that to the array. We can go on to modify, add the value random x position to end. Now we can create the second array, and we'll give it a similar name, ypos of all drop pixels. We're going to set the y position of all the drop pixels to an empty array. But in this case, we also want to control the speed that the pixels are dropping. And for the bigger level, we want there to be a bigger gap. For the smaller level, we want there to be a smaller gap. To do that, we're going to have this idea of a clock. Every time a clock in a game ticks, it runs through maybe a loop, a part of the code. And then the next tick of the clock is the next time it runs through the code. You can think of it like a frame that you might see. So it's not necessarily 1 second, it's probably much faster than 1 second, but it's something that we can use to control the speed of the game. We can set the time between ticks of our clock, and then we can also set how many ticks happen between each pixel dropping. And so we're going to create a variable called drop frequency. This is effectively the number of ticks of our internal clock between each pixel falling down. So in level 1 we could have 5 ticks, in level 2 we could have 4 ticks, and level 3 we could have 3 ticks. So we need to have some maths here, and we're just going to say that the drop frequency is 5 minus the current level. Because as the current level gets bigger, that means that the drop frequency will be smaller. In other words, the pixels will drop more close together. Now what we're actually going to do with our second array is we're going to create a y position for all the pixels before they've dropped. It might look like they're just appearing from the top of the screen, but it's more like you've got a piece of paper with all the drop pixels on in a large column, and as the game is being played, that whole piece of paper is just being slid down. So we have to make all those marks on the piece of paper first. And we just do that in exactly the same way as before. We want to create exactly the same number of values. So effectively the first line on our microbit is 0. And the line above, which doesn't exist, is -1. The line above that is -2, is -3, is -4. We want the pixels essentially to start at -1. And then we want to plan on this imaginary piece of paper, all the pixels above that, they're all going to be negative. So whatever we do, we need to multiply a number here by -1 to make sure that we can make them all negative. Now we can take the drop frequency and we can multiply that by the index. When this loop starts, the index is 0, and so 0 multiplied by whatever is going to be 0, and then, oh, that also needs to be in there, thank you, and then 0 multiplied by -1, well, it's still 0. For the second pixel, the index is going to be 1, so it's going to be 1 multiplied by the drop frequency. For level 1, that's going to be 4. So that will be in a y position of 4 multiplied by -1 is -4, so it will be above. The third pixel will have an index of 2, and so 2 multiplied by the 4 for level 1 means it will be 8, and multiplied by the -1 means it's -8. So the y positions are going up in 4s for level 1, or 3s for level 2, or 2s for level 3. I think before we continue with making the level, first is make sure that the buttons A and B control the movement of the X position and the Y position. So we need to go like this, I'm just going to make it clear. When the game state is equal to 2 and the player is playing, and the player presses the A button, we want that to mean that the character moves to the left. And that is a change in the X position of -1 because it's going towards the left-hand side. It could keep going off the screen, and we don't want it to go off the screen. So first we need to just check that the player X position is greater than 0. If it's greater than 0, it must be 1 or 2 or 3, and therefore you can move left. Okay, that works, but we do have a little bit of a bug, which is that we're not plotting the X position of the player to start the game. So I'm going to go back here and I'm just going to put that into there. Level 1. There we go. There we go. So now we've got the player's character moving left, and it shouldn't be able to move off the screen. Great. Well, for the B button, we could have that do basically exactly the same thing so far, and to do that we just need to duplicate the whole A button situation. We just need to change a few of the ideas. So that should all work. Let's just try it in the simulator. Level 1, and there's the player. We can move left, we can move right, so everything looks great. Looks like it's all working. Okay, well, now we've got a lot of the background of the game set up, and we've got the player working completely fine, so we just need to work on the rest of the game, which we'll do in part 2.